When we think of rivers, we picture them from above. We see them slashing across continents, carving out massive canyons, and defining the landscape in broad, visible strokes. But in certain regions, the bedrock is composed of carbonate rocks, like limestone. These areas are known as karst landscapes, and here, water does something highly unexpected. It finds every crack and fissure in the stone, and it simply drops out of sight. A river swallowing itself into a sinkhole doesn't just end. The surface geography vanishes. But below ground, that flowing water becomes a massive, unseen geological engine. The scale of these hidden voids can be deeply unsettling. When explorers first tried to map Tennessee's Lost Sea in the early 20th century, a caver named Ben Sands threw mud balls into the pitch-black space around him to gauge the size of the room. All he heard from every direction were distant splashes. In 1990, Ho Khan ducked into a small limestone opening to escape a jungle rainstorm. From the blackness inside, he heard the roar of water. That sound led explorers back to the mouth of Sandan, the largest cave on the planet. To understand how surface water engineers the largest hidden voids and the most bizarre ecosystems on Earth, we have to leave the sunlight behind and follow the river down. The journey down begins in the entrance zone. This is the narrow bridge between two worlds, where sunlight still manages to pierce the darkness, allowing ferns and mosses to cling to the wet rock. This diagram shows how caves are born. As rain falls through the soil, it picks up weak natural acids. When that slightly acidic water hits the limestone, it dissolves the rock through a process called chemical weathering. Continuous mechanical slow and chemical weathering compound over millions of years. Those tiny dissolved cracks slowly hollow out into sprawling subterranean highways. This relentless interaction, water slowly eating carbonate rock, is the foundational architecture for everything that happens deeper underground. Once the light completely vanishes, we enter the transition zone. Here, the architectural scale of the cave explodes. Look at the tiny expedition tents dwarfed by this single chamber. In Vietnam's Son Doong, the river has carved a continuous, open passage stretching for 9 full kilometers. The voids are large enough to fly a commercial airliner through. The water carves downward as much as it does outward, hollowing out multi-story subterranean canyons that remain entirely hidden from the sky. The river also regulates the entire internal climate. Its constant flow maintains a steady internal cave temperature of about 17 to 22 degrees Celsius year-round, regardless of the weather on the surface. That stability shatters during the rainy season. As millions of gallons pour into the sinkholes above, the underground river can surge up to 100 meters in height. The current rips massive tree trunks from the jungle and violently wedges them into high cliff walls deep inside the cave. In the absolute dark of the transition zone, the river acts as both an unstoppable physical architect and a masterful climate controller. Further down, the roaring rapids give way to the deep zone. The river pools into still, submerged labyrinths. To explore these reaches, humans require advanced scuba gear, descending into claustrophobic passages 77 meters underwater. And yet, life thrives here. The animals that spend their entire lives in this pitch-black environment are known as troglobites. Without sunlight, they have no need for vision or camouflage. This crayfish is completely blind, and its skin lacks pigment entirely. Because there are no plants in the deep zone, it relies entirely on the river to wash down nutrients and detritus from the surface world. Because they can never leave, these populations are deeply isolated. A single species of blind salamander or fish might exist only within a specific cave, cut off from the rest of the planet's evolutionary timeline. The deep zone contains fragile, closed evolutionary loops. They are alien worlds existing right beneath our feet, dependent entirely on the steady pulse of one underground river. It takes millions of years of immense geological power to hollow out a mountain, but the biology inside that rock is terrifyingly fragile. This diagram shows the paradox of karst topography. Normally, sand and soil filter water, but in a karst landscape, water drops through open fissures with zero filtration. If agricultural chemicals, petroleum, or human waste wash into a sinkhole, they travel rapidly into the deep zone. When that pollution hits the underground river, It dismantles the isolated food web instantly. Highly sensitive troglobites, adapted to pristine water, are wiped out. Once they are gone from that specific cave, they are gone from the earth entirely. But the consequences don't stay underground. Those same unfiltered subterranean rivers eventually resurface. They feed the springs, the municipal wells, and the aquifers that millions of people rely on for drinking water. This is why responsible caving and land management are so crucial. Protecting caves is about preserving rare geology, yes, but it is also a direct line of defense for our own water quality above ground. The ground beneath our feet feels solid, but it isn't. It is a highly vulnerable, flowing engine where every action on the surface ripples straight into the dark.